Okay, now we have some examples of test of permutation and combination. Now we need to test ourselves which among these could be a permutation and combination. Just if we have mastered the difference between the two, we need to understand which is a permutation and which is a combination. So let's have come across, as I told you, the moment something comes, there is going to be a slide. Pause the video, keep a paper and just write down whether it's permutation, combination among all the examples that have been given. So here you have a situation, the first lot of situations. How many three-letter words can be formed with the words Gujarat? Remember, it's three-letter words. The words may make sense, may not make sense, but three-letter words. Ways of selecting four letters from examination. Now, I'm reading this out for you, assuming that you have started working. Now, we'll go back to how to discuss, so you get some time to decide which among these is a permutation. In how many ways 3 out of red and 2 out of black balls can be selected? There are 3 blue balls, 4 red balls and 5 green balls. In how many ways can they be arranged? In how many ways can we arrange 4 letters out of 7 letters? Number of ways in which 6 men can be arranged in a row. How many ways 3 students out of 10 can be selected for a trip? The total number of ways in which 6 pluses and 4 minus signs can be arranged in line. So we have these examples, 8 of them. So let's go back to the first one. I hope you have been able to crack it. How many 3-letter words can be formed with the word Gujarat? Now you have to understand, is this a mere selection or just an arrangement? So you have to decide what it is. Now suppose you've selected 3 letters G, U and G and you need to make words. Now GUG is different from GJU, which is different from JUG. So there are so many possibilities, and since we need to form words, say for example, if you want to make with pan, P-A-N-N, pan you could make, or it is nap. Pan is different from nap, much the same way GUJ is different from JUG. So hence it is definitely a case of arrangement. So it's an arrangement, hence what do we have? Yes, it's permutation. You can give 1 mark to yourself if you have done that. Now, we need to select 4 letters from examination. Now here it's not asked that you need to make words. You need to just select any 4. So suppose you select E, X, A and M, or you select X, A, M and D, or X, M, A and D. It doesn't seriously matter because you just need to select. The order in which you're selecting is not important. Hence, what do we have here? It is just selection. The word selecting makes it very, very easy. That is definitely a case of combination. It's a combination. Also note that even here we selected, but we went beyond selecting. We first selected and then arranged. In how many ways 3 out of 8 red, 2 out of 5 black balls can be selected? Now all of them are red of them. Now out of them it is only again a case of selection. So when it is a selection, it's definitely a case of combination. Then there are 3 blue balls, 4 red balls, 5 green balls. In how many ways can they be arranged? So now you're selecting 3 blue balls. It's possible you keep all the 3 together, then 4 and then 5, or you introduce red in between and 5 in between one of the green balls. There are so many ways in which the order can be changed. Since arrangement, it is an arrangement, the order is important. The order of arrangement is important. Hence, what is it? Is this a combination? No, it is a clear-cut case of permutation, right? So if you guys have got all these 4 right, please, you can accord yourself 4 marks. In how many ways can we arrange 4 letters? Again, we have a case of arrangement. So if it's an arrangement, it has to be a permutation, right? The number of ways in which 6 men can be arranged in a row. Now, this could be a row for a photograph. It could be a row for maybe handing over some awards or medals. So here maybe the person who gets the gold medal stands first, then the silver and the bronze and the various other ones. So the way in which it is arranged, the order of the 6 men who have been selected have to be arranged in a particular manner. So the moment you have arrangement, the order is important. So definitely this is a permutation. How many ways 3 students out of 10 can be selected for a trip? You just need to select them. So you may select any 3. The order in which you select A, B and C, whether you select A, B and C or B, A and C, B, C, A is vestigial. That's not important. So hence this is just selection, hence a combination. Then the total number of ways in which 6 pluses and 4 minus signs can be arranged in a line. You're talking about arrangement. Since it's an arrangement, definitely it's a permutation. So we have this one is a permutation, the first one. So you can just check up your answers. I hope concepts are slowly getting clearer. Let's take up more examples. Okay. Now here we have 10 examination papers are arranged. Maybe for a set of exams, there are 10 examinations. You have anything, maybe you may have law, accountancy, various types of papers. Now we all understand, whenever we appear for major exams, what comes first, what comes second, ultimately the same set of topics that are going to go, same subjects that are going to be covered. But it does matter as to which subject appears first, which appears last, and which appears a third, how many holidays do we have. So the order in this case is important. So definitely it's a permutation. Out of 15 managers, 5 are to be selected. How many ways can this be done? You're selecting 5, selection again, any 5. Order is not important, so definitely it's a combination. Number of ways in which 7 boys sit in a round table. When you have a number of boys, they're sitting around a round table. So it could be A, B, C, D, E or A, C, D, E, B, A, D, C, E, B. It's the same 7 boys. But there is not, if you're just taking just the 7 boys, if you take all the possibilities, it's not the same. Each possibility is different. Who's to the left of whom? Who's to the left of A? Who's to the right of A? Who's to the left of B? Who's to the right of B? Same way for C, D, E, F, G, whatever. The arrangement in which it's done, the order in which these things are arranged is different. So in that case, it's definitely a case of permutation because the arrangement, we have an arrangement. Then, a polygon has 44 diagonals, then the number of its sides is what? Now here there are 44 diagonals. So each diagonal is going to join 2 points. So the diagonal could be called AB or AC or it could be called CA. Both mean the same. A diagonal joins any 2 points that have been selected. So whether you arrange A first and then C or you join it from C to A, it means the same. So it is basically just selecting 2 points or 2 vertices of the polygon and joining them. 2 non-consecutive vertices obviously and join them, you get a diagonal. So any 2 non-consecutive, the order in which you're selecting A and C or C and A is not important. So it is just selection. So definitely it is a case of combination. Then again, the number of triangles that can be formed. We are talking about the number of triangles that can be formed from a set of 6 points. So suppose 6, obviously it is understood that it will be a 6 non-collinear points. You are selecting and saying that number of triangles. So you may have triangle ABC or triangle ACB or triangle BAC. Suppose you are choosing A, B and C. You call it as triangle ABC or you call it as triangle BCA or triangle ACB. All mean just one single triangle. You can name a triangle in so many different ways. Hence, eventually it is just selecting 3 points out of them and joining them. So it's quite similar to this. So this is also a case of combination. If they ask you the various names of the triangles that can be formed from a set of 6 points, then what do you think? Will it be a combination? We are naming them, various different names. So there the order in which A, B and C arrange or D, E and F are arranged, the order is important because the naming becomes different. So if the same question is told that the names of number of triangles that can be formed from a set of 6 points, then it becomes a permutation. But here it is only the number of triangles. Okay. Then you have a case here, the number of ways in which 8 sweets. So we have the number of ways in which 8 sweaters of different size can be distributed among 8 persons of different ages. Now what this is not important. You can even take it as sweets. It's okay. So So again, you are, which it can be distributed among 8 persons of different ages. So the order in which these sweets are distributed, different sizes, can be distributed among 8 persons of different ages. So we have a case wherein different 8 sweets of different sizes can be distributed among 8 persons of different ages. Now here the sizes, you're selecting them. So this would be one, maybe you're picking up one and giving out of the 8, you're giving the smallest one to A, the other one to B, and the third one to C. Or you could change the order in which you're selecting the sweets and giving. So a different person gets a different size of the sweet. So here, just suppose you're selecting 3 sweets out of that and giving it to 3 people. Now who is getting the biggest, who is getting the smallest, the order is important. In such a case, it becomes a permutation. On the same, suppose it is just told they are all the same size on the same types, then all of them are going to get the same, then it only involves selection. But moment you have different sizes, you need to distribute it. Who gets the biggest is going to be different. So it's definitely a case of permutation. Then, how many 6-digit telephone numbers can be found by using 10 distinct digits? So here, suppose you're choosing 1, 2, 3, 4, 5, 6. You're just selecting, but that's going to be different from 2, 1, 3, 4, 5, 6. So the order in which these digits are arranged gives so many different types of telephone numbers. So it is not just about selecting the digits, it's about arranging the digits too. So following the selection is the arrangement. So definitely it's a case of permutation. It's a simple case of permutation. Hence we have this particular case. So this is how we have. Let's take a few more examples maybe. Okay, we have a few more. I hope you're testing yourself along with me. Now I'm also testing myself. In how many ways 3 friends out of 8 can go for a movie? So there are 8 of them, out of which 3 are going. Now A, B and C takes, the order is not important, so it's a clear case of combination. How many ways 5 persons can stand in a line? So it is an arrangement. So it's a permutation. A building contractor needs 3 helpers and 10 men apply. In how many ways can be selection? Selection, it is clear-cut case of combination. Out of 7 gents and 4 ladies, a committee of 5 is to be formed. Now it could be all 5 gents or 4 ladies and 1 gent, or various possibilities. But you select, whom you select first and whom you select second is not important. So it is only a selection. Hence it is combination, because the order is not important. Now here again, every 2 persons shake hands with each other in a party, and the total number of handshakes is 66. So if you have A and B shaking hands, whether A shakes hands with B or B shakes hands with A, it's a mutual process. So both mean the same. So the order in which A shakes hands with B or B makes the first move is not important. We are only saying how many people shake hands. So it's a clear-cut case of combination. A candidate is required to answer 6 out of 12 questions, which are divided into 2 groups containing 6 questions in each group. Now you just have to select any 6 out of 12. So you may have to select 3 out of the first 6 or 3 out of the second 6. Now how you select, the order in which you select first and then you attempt first is not important. What is important is the selection. So selection case, so it's a clear-cut case of combination, right? So these were a few examples. Let's see what we have, a few more ways in which we have. Just to brush up, we have a case of a Supreme Court bench consists of 5 judges. In how many ways the bench can give a majority division? So it eventually decides about who are the people who will be in favor of the decision and how many of them are not in favor. So here again, the order is not important. You have to select 3 or more, how many ever judges out of these 5. So it is a selection case, so it's definitely a case of combination. And then again, you have 5 bulbs, of which 3 are defective, are to be tried in 2 light points in a dark room. So there are 2 light points and there are 5 of them, out of which 3 are defective. So obviously you have to, when you select them, you have to select them, and then ultimately we are concerned about which is defective. So the order in which it is tried is not important. What is important is you are trying bulb number A. So you try bulb number A before bulb number B, or bulb number A after bulb number B. The order is not important. So it is just testing, selecting and testing. It's a selection. So definitely a combination. Okay. On the contrary, you have 6 seats of article clerks are vacant in a chartered accountant firm. How many different batches of candidate can be chosen out of 10? So there are 10, out of which you need to pick up 6 for the same chartered accountant firm. So in that case, definitely it is, what is important is you're selecting. So, and just introducing. So A, B, C, D, E, F. Now you may select A, B, C, D, E, F or B, C, D, E, F, A. It's all the same. You have combination. Let's take a little bit of a deviation from this. Suppose the same thing is 6 seats of article clerks are vacant in 6 chartered accountant firms, and you need to choose the 6 from among 10. Now here, who goes to which chartered accountant firm is important. The order is important in such a case because it's not just one single chartered accountant firm. So you could select A, B, C, D, E and F maybe. So A could go to firm number 1, B could work, or you could change the order. It is a different process. So the arrangement is important. In that case, it becomes a permutation, just a deviation from this. So we had a number of about 20 examples to make you understand, and also for you to test as to how to judge which is a case of permutation, which is a case of combination. And I'm sure we'll be able to carry forward and apply these things further. So, further, let's see what we have in hand. Okay, now we have more. We have more coming up. You have how many 3-digit numbers can be formed from the digits 0, 1, 2, 3, 4, 5, 6. So we have 3-digit numbers out of this. So the number, the order is important. So definitely a permutation. A person has 8 friends, number of ways in which he may invite one or more. Order is not important. So it is a combination. Number of ways in which a person can choose one or more of the 4. So he may choose a TV, or he may choose a TV and a refrigerator, or a refrigerator and a TV, both mean the same, or TV, refrigerator, washing machine, or washing machine, refrigerator, TV, all mean the same. So the order in which he chooses, so it's basically a selection or choosing. So it's a clear-cut case of combination. Then a question paper contains 6 questions, each having an alternative. The number of ways an examinee can answer one or more questions. So he just has to pick up answers, 6 questions, and number of ways the examinee can answer one or more question is going to be, the order is not, he may choose question number 1 first or question number 2 first, and then he goes back to 1. The order in which he chooses is not important. Which questions he selects, that is important. So here again, it is a case of selection, so it's a combination. Again, there are 5 books in a library. In how many ways can a person borrow 2 books at a time? So it should be at a time. 2 books at a time. So out of these 5 books, he could pick up 2 books, 1 and 2. Now whether he picks up 1 and 2 or 2 and 1, both mean the same. Order not important, so it's a combination. Okay. Then there are 5 speakers, A, B, C, D and E. The number of ways in which A will speak always before B. So A and B will always follow this pattern of A speaking before B. C, D and E could be arranged in so many different ways. It could be C, E and D, C, D and E, D, C, E, D, E, C, D, E, C, E, D, C, E, C, D. So the order in which C, D and E are arranged is important because who's speaking 3rd, 4th, 5th out of these 3? It's like giving gold, bronze and silver medals to 3 people. Who gets what is, the order is important, and hence it's definitely a permutation. Hence, we have all these examples tell us about the importance of how we can judge whether, if a given situation has been given to, whether we need to use the concepts of permutation or the concept of combination is something which can understand by just a few simple tests.